parametrize the line segment through A at 2, minus 1, 5 and B at 4, 3, 2. Use the equation to find the midpoint of the segment. Okay, so parametrize, we kind of want to express it in a parametric way, so I'm thinking coordinates, you can write that as a kind of vector as well. It doesn't really make much difference. The general principle remains the same. To find an equation of a line in some vector form, whether it's in a parametric form or just as a vector equation, you need a position vector that gets you on a line and a direction vector that keeps you on a line. So I can use the position vector of A or B to actually get us on the line, but then to keep us on the line we're going to need AB. So that is clearly a vector that's parallel to the line, the straight line from A to B. So we start there. AB equals the position vector of B minus the position vector of A. So B is 4, 3, 2 and A is 2, minus 1, 5. 4 minus 2 is 2, 3 minus 1 is 4, and 2 minus 5 is minus 3. Okay, so that is AB, that is our direction vector. So A vector equation of this line, you could say x, y, z equals, well, I'm going to use the position vector of A. So that is 2 minus 1, 5. Plus t times the AB, the vector AB, which is the direction vector of the line, so 2, 4, minus 3. Okay, so that gives us the vector equation of the line infinitely, but we've been asked for a line segment. So a line segment means we're only interested in the bit that goes between A and B, and actually it's general convention to not include the endpoints, right? So if you think about this, if t was 0, then we would be at point A. So if we had 2, minus 1, 5, remember that's the vector that gets us to point A, plus 0 times this direction vector, we're obviously at A, right? If t was 1, then we start at A and then we do AB. Remember, this is AB. So obviously if we start at A, and then we do AB, then we're going to go to B. So t needs to be between 0 and 1. T needs to be smaller than 1 and greater than 0. Now, I personally, I have a little bit of an issue with that. I think it should include 0 and 1, but standard convention says no. Okay, so that's a vector equation. If we want to sort of define it parametrically, well, you could either say something like this. So x equals 2 plus 2t, y equals minus 1 plus 4t, so 4t minus 1, and z equals 5 minus 3t, and t still needs to be smaller than 1 and greater than 0. So that's one way to define it parametrically, or we could say r as a function of t equals, and I'm just going to write all of these in a vector, so 2 plus 2t, 4t minus 1, and 5 minus 3t. Like that. And to turn it from a line, as in an infinite line, to a line segment, we need to make sure we control the domain of t. So it needs to be between 0 and 1, not including 0 or 1. Okay, the second part, we've been asked to use the equation to find the midpoint. Now the midpoint happens when t is a half. Okay, so midpoint is going to be, we'll call it m at, so it's going to be 2 plus 2 times a half. Remember, t needs to be a half for the midpoint. So 2 plus 1. For y, it's going to be 4 times a half minus 1, so that's 2 minus 1. And for z, 5 minus 3 times a half, or 3 times a half is 1.5. So 5 minus 1.5. So that means that m is at 3, 1, 3.5. Okay, so that's the midpoint. And for the parametric equations for the line segment and not the line, one of these two layouts would be most common, but there are others.